distributed property. So our first step is obviously plain old boring given. You were given something to do. The next thing then, what we did is that we would just kind of draw our rainbows, our arrows to show that we have to multiply in both parts. And we would say that we would write it out long form and say it's going to be 6 times 2 minus 6 times 2y, 5 times 2y minus 5 times 2. Yes, ma'am? Ew. No. I'm joking. Yeah, absolutely. Jeez, you two, will you stop arguing? It's like your brother and sister. Ah, you see what I did there? What did I do? What did I do? Simplify. Very good. Guys, take out your homework, guys. Come on. So I simplified here. Now what do I do? Pick on the little guy. So if I pick on the little guy, I'm going to add the 12y to both sides. What property tells me I can add things to the same to both sides of an equation? Very good. There's your add prop equal. And then what do you do again? And then we have to do another add prop equal. Thank you. Another simplify. And so when you're walking through these things, basically the biggest mistake you make is you just make something stupid. Don't do something stupid. Okay. And the other thing that's nice about these is that as you go through them, the purpose behind writing out step by step by step by step is really to make sure that you slow your brain down. I hate her. Congratulations. Yes, ma'am. It looks just like 13 we did in class. Different numbers. Exactly the same thing. That's why I did 13 in class. I can walk you through the start of it.
I like this stuff. And I say we should just keep it.
That's the same way you were saying. Guys, a lot of times in this, I knew that I was going to assign you one that looked like some. I knew I was going to assign you one that looked similar to this one. That's why I did one that looked similar to that. Yeah, that's okay. So what happens here is I'm just going to go ahead and, because this takes a lot of steps. kills me.
Hey, it's okay. I gotta go. Let's see you do a Murphy.
We're so close, so close. When I try so hard.
It's a running gag between her and I with this whole stupid marker and the whiteboard thing. I did that once and just kind of kept saying, one of these guys are going to get it. She walked up here one day and just stood here and went, landed right away. And she's like, give me it again. Landed again. I'm like, every time. She just can throw it on a whiteboard.
Well, congratulations.
I know, right? But no, whatever. Anyway, so what I'm going to do is multiply by 8 on both sides. It doesn't matter if you multiply by 8 first or the 4 first because you have to show that you have to get rid of it both times. So this is your multiplication. There's your multiplication property. Okay. That 8 goes away. Now it just becomes an 8 times the quantity 3 plus y over 4 is negative y. And what we did there is simplify. What's that? I haven't gotten that far yet. Now my next step is to multiply the 4 to the y. And now you multiply that through. You just have to do it twice. So you have 8. All right. Now what do you have to do? Distribute. Good. Now I can show you the distributive property.
That's not funny.
After you distribute, what's your next step? Simplify again. Yep. And granted, I know, ladies and gentlemen, in this problem here, there are so many shortcuts to go through it that you would do normally. But when you're doing algebra proofs, they really are just to get your brain set ready to do a geometry proof, whether it's a segment, an angle, or triangle, because you get to those, you wind up having to be so unbelievably specific in what you guys are doing. This is just a precursor to it. It's just helping you learn how to slow your brain down to show step by step. From here, normally what we would do is we would pick on the little guy. And if I picked on the little guy, I would move that negative 4y over, which would mean one side would be equal to 0. So instead of doing that, I'm going to move the big guy over. It happens from time to time that I do that instead. The reason I'm going to do that with this proof is it takes one less step if I do it that way. So I'm going to subtract the 8y. So here's my simplify. Subtraction property of equal. Hey, look, another simplify. Division property. Solve. So we have a simplify. Division property. And solve. What's that, sir? Yeah. Did you forget the negative when you rewrote at some point? And
Because I got 36.
8 times 3. Is that what you did?
That's great.
But here's the thing. Let's say you did that. You mathed it correctly. I'd take out half the point because you're an idiot. But I wouldn't take off the full thing because you know what you're doing. Why not? It's just how I am. Yes, sir. Oops. Make sure, yes, sir. Yes, sir. Make sure your names are on the, whatever was all on that worksheet, those 2 days worth of stuff, make sure your names are on it. Pass it forward, please.
Oh no, I'm just but all I know is that we don't I'm like getting them. That's when I started believing. Well, they used to, then they lost it. I think I'm sorry. I hope you won. Before, I came back, and then I was trying to because I was playing
Thank you, ladies. Thank you.
No, we don't even have it.
Why would I need? I have 1, 2, 3 laptops. Why do I need another one?
Because why not? Because that in case of a call the other day for one straight. Yeah. Derek, what you doing?
Yeah. Yes, I will take it. Okay. All right. So what I want to talk about today is something a little bit. It's going to be a little bit different than what we've done in the past. Is that?
What is going on?
Nice.
Actual stuff, like school stuff.
What I want to talk about today is a little bit of what's called proof progressions. And
Whoever did that?
I didn't put it there. I teach them. The children need to learn. It is going to be mixed a little bit of 2.6. I know that originally my notes put 2.7. I actually put the wrong one in there, but don't worry about that now. What I'm beginning to talk about here today, guys, is that at some point in time, we are going to get to looking at things that look like this. Don't write this down just so I can show you what's up. Give it over. What most students have a hard time with is when we get to eventually to the point of working with triangle proofs and things of that nature, is that we have a hard time knowing where to start. So what we do is I try to show you guys a different way to organize definitions, theorems, and things like that. So that way they're on one piece of paper. They kind of work out to be your how-to sheet, like the instruction manual, if you will, of how to do these. So what overwhelms students for the majority of the time here is that when they see something like where it says BC is perpendicular AD and BC is the angle bisector of angle C, prove the two triangles are congruent. People see all that information, they're like, what? What does that mean? So what I try to do with this is that I try to show you guys that we can break down. What I try to do is break down the definitions and theorems and stuff into a meaningful order. So that way we can find them more readily, so that way we know what to do and when. Now, we're not to the point yet where we're ready to even remotely come close to this. This is going to be still a few weeks away, but what we are getting close to doing is we will tomorrow, especially, is we're going to talk about some proofs with angles and with segments. But what I want to do today is kind of get the scariness factor a little bit out of there by working you through what I call progressions and what does it look like and what does it mean and how do we write it down to keep our thoughts straight. So let's look at a few of these real quick. And as I was telling you in other classes, don't lose this. These are sheets that I allow you guys to use on quizzes and tests and stuff. So these are like super, super, super important. Also, today we're only going to fill in like 2, maybe 3. That means that as we go along, as we go through, as we start to add more and more of these, I will start to remind you guys, hey, we just got done with like 4 of them. Take a picture of it. Because if you lose this sheet, you'll lose the sheet. Guarantee you're not going to lose the phone. What's up? Guaranteed. All right. You guys see any more? Yeah. Good enough. So, all right. Now, what I want you guys to do is not write anything down yet, because a lot of times in class, we'll come to a point where I'll say, hey, I will draw a square, and when I put a square on, that usually means, hey, we're going to fill in a square. So, excuse me. One of the easiest progressions that I think that we start out with in geometry is a super simple definition, because that's what these are going to be for. Progressions are going to be used for definitions. Is midpoint. What does midpoint do? Yeah, it cuts the segment into 2 congruent parts. So what I think of it is, when we're talking about these progressions, if you will, is that they're going to be a sequence of if-then statements. For example, and don't write this out yet, I'm going to show you how this works. If given a midpoint, if you're given a midpoint, then what is created? I just said not yet. I wanted to explain to you guys the process here, so just pay attention. That's all I'm asking you to do. Again, what does a midpoint do? 2 congruent parts. What's created that's congruent? Are they lines or are they segments? Okay? Because segments will have actual measurable distance. They'll have measurable value. So if you're given a midpoint, then what's created? Segment congruent to some segment. Okay? That is as generic of a definition of midpoint as you could come up with. Nothing else occurs. Midpoint, some segment, congruent to some other segment. Now, as we go into these progression things further, what I usually do, it's not on your phone. Yeah, thanks. Is I usually put in examples. Because when we have examples, we might visualize a segment. We might visualize letters. We can see where things are coming from. We will understand how the flow then works. So for example, if I say that A is the midpoint of XY, what would that look like? A is the midpoint of XY. What does that look like? Careful in your letters. You're just saying a point is there. So say it again. There you go. Yeah. You're just saying the points themselves. Okay. Now he's right. So what I would probably do then is I would just make off to the side some segment XY, and A is in the middle of it, isn't it? In a diagram, how do you mark that? What do we put on there? Exactly. We put these little tick marks. Remember how we did that before? So in words, it says that A is the midpoint of xy. Visually in a diagram, it would look like that. XA is congruent to AY. Now, as far as a proof is concerned, that means we're looking at it via two columns. Statements, reasons. What you're saying, why you're saying it. Here's the example. If I'm given that the value that A is the midpoint of xy, that's given, then, if given a midpoint, then segment congruent to segment. Well, A is the midpoint of xy, then XA is congruent to AY. What definition did we just use? Midpoint. Exactly. The reason? We just used the definition of a midpoint. That's what progressions will look like. You'll hear me talk about them a lot. I use them. I'm getting more and more of the math teachers to turn to this because it makes your life a lot easier as far as knowing where to start and why. So if you have a part in a proof that says, hey, Z is the midpoint of AB, well, AZ, ZB, they're congruent to each other because definition of a midpoint. The lettering will change, but the definition never will. The definition always stays the same. Okay? So now, what I would do for your first square then is fill in something like this. Right? Basically, not just like this, fill this in like you see it. And then we'll talk about another one. And we'll walk through that one together. But I wanted you guys to see why I draw it that way, why it's put together. Because if you know that you start with something, whether everything in geometry has some specific definition tied to it, midpoint, angle bisector, perpendicular, parallel lines, whatever. Every definition has something that creates something else. This is how we keep them all straight, just by using these. So take a minute or so, throw it in there, and we'll talk about another one here in a second. Oh, no. No, I sorry. Another super easy one to talk about is an angle bisector. What's an angle bisector? Very good. Bisects an angle. So if you have an angle bisector, what's created? So see where I'm going with the idea of if you're given a midpoint, what's created in 2 seconds. If you're given an angle bisector, what's created in 2 angles. And you see how why I like this paper that way we don't see it because you can get information over this helps break it into smaller chunks. This helps break it down all the stuff in small chunks. Really is useful. When you guys not there here, I'll show you an angle bisector and talk about a couple things from the page. All quick. Super exciting. What? I haven't gotten there yet. If you're given an angle bisector, then what is created? Okay. So if given angle bisector, then what's that? What? So if I'm given an angle bisector, then we know somewhere some angle is congruent to some other angle. So just like I did with midpoint, what I'm going to do is draw a small diagram and then draw it in via two columns so you see the idea of how you put it all together. For example, BX bisects angle ABC. Yes, ma'am. I'm just pulling letters out of thin air. So, what would that look like? What's the big angle? Yes, sir. All right, angle ABC is the big angle, so I just draw. And where does BX go? Right in the middle. Yep. Now, according to that diagram, what two angles then are congruent to each other? Excellent, excellent. ABX and XBC, very good. Are you okay with that? Okay. With scissors, please. Stop scratching up my desk. Let's see it again. I'm going to chart. We put it in now via what would look like our T chart, our two columns for statements, reasons. What you're saying, why. DX bisects angle ABC. BX bisects angle ABC. Oh, and you're probably going to write these in your squares. Borrow something. Somebody's going to have to. And just like you guys said a second ago, we know that angles ABX and angles XBC would be congruent because that's what the diagram said, because that's what the definition tells me happens. So I would say angle ABX congruent, angle XBC. And what definition did you just use? Angle bisector. Yeah. Make sure you say angle bisector, not just bisector, because when you have a bisector of a segment, yeah, bisector of a segment doesn't create angles, does it? Create segments. You just gotta be careful. Again, it's the idea of being extremely literal with what you're talking about. Definition, angle, bisector. Okay. These are proof progressions. These are how you're going to put proofs together. These are how proofs are going to work. It's how, when you have specific information to start, it's how you make that next step of what can you say. So now, if you have any given statements, whether it's triangle statements, angles, whatever, if any of them say you have a midpoint, if any of them say angle bisector, you know definitively what to do next. Segment convert to segment, definition midpoint, angle convert to angle, definition angle bisector. That's how this works. It tells you how to do it. But more of the other stuff that we're looking at today is kind of just plain old boring review. For example, what makes a linear pair more specific, get supplementary angles. What makes linear pair more specific? Yes, sir. Right. Yeah, I don't know if we guys heard of linear pair has the word what in it? Line. Which means that there's a pair of angles that make a line. Supplementary just means it can be anywhere. Okay? Linear pair two angles that are next to each other create a line. Well, there's a 30. There's a 150. Those are still supplementary, they just still make a line. Okay? That's review. We knew that. What about complementary angles? What are those at equal? Okay, what are supplementary angles at? What about vertical angles? Are you sure they added 360? What do we know about vertical angles? What's specific about that? They're like that, but what do we know when you draw it like that? Okay, that's what I was looking to see here, because they don't necessarily, each vertical angle, these two are vertical angles, but they don't add the 360. Okay. They're just congruent to each other. Angles that share the common vertex, whose sides create opposite rays. Now, when you have do I have enough information here?
No.
Nobody yells at me.
Wait, we're doing that. They look very similar.
Oh, yeah.
And they're very similar, like they're the exact same.
If I go around, disclaimer.
I know.
A little actually.
What's angle A have to be? Okay, are you okay with that? 70? All right. What's angle B? What do you have to find out first? What do you figure out? Okay, but you're making it hard. Yep. That has to work there. And now these things add up to equal 180. They create a line, which makes it. Now, what you were saying isn't wrong, but you would have to do a lot more math. You'd have two angles that are the same, so it would be 2x plus 30 plus 70 plus 30 plus 70 equals 360. It would have got to be there. There wasn't wrong with it. You're a complicated world. Yeah, just make sure you see that. The stuff that you're looking at tonight, then, it's on page 144. It's a lot of angle pair stuff just like that. There's nothing super crazy or difficult. I'm not saying, no, you're not going to need those progression sheets today. I want you to do those progression sheets today because that'll give us more time to work on. The reason why we did the progression sheets today to start them is so that way tomorrow it'll be a little bit easier to work on why they work. So, real quick, the questions 26 through 29. They're going to ask you a couple of things. They're going to say that angle A is twice the measure of its complement, angle B. Angle A is twice the measure of its complement. So, what do complementary angles have to be equal? They have to equal 90. So that means that A and B have to have equal 90, right?
Yeah.
What does the word is mean in math? Equals, good. So that means angle A is twice the measure of angle. You guys remember a little bit of thing called systems of equations?
Yeah.
Algebra 1? This is what we call a substitution step. Everywhere I see an A, I'm going to put 2B. What's 2B plus B? And you get? So if B is 30,
60.
that's 26. 26, 27, 28, and 29 are all very, very similar to that. Either complementary or supplementary, doubling an angle, or half of an angle. If I take half of an angle, what am I multiplying it by? Half. I know it's a lot to ask for here, guys. It's only Thursday. What's that? I got you. Yes. Yes, yes. All right. Give it a shot. See how you do. Tomorrow, like I said, don't lose that progression sheet. I will show you guys why I walked you through those two today. I will probably have time to add maybe 2 or 3 more as well. No, man. Yeah, no assessments at all tomorrow, guys, so don't worry about it.
I'm so happy. Yeah,